Hey guys, so today I'm going to talk to you about my experiences monitoring models in production. I'm Lina, I'm the machine learning lead engineer at DKB Bank here in Berlin. Before I was a senior research engineer at Zalando. And you might be wondering what the 30 models were about. So it was a variety of models, a lot of recommender systems, personalization, NLP in customer service, and some finance-related models. And they're mostly large-scale production systems, so I hope what I learned can be useful for you. Okay, so if you look at some of the machine learning tooling, you might get a little overwhelmed because the space is really large, developing kind of fast, and there are many different tools out there. So what I'm showing you today is my monitoring blueprint, which is a much simplified version that I found useful for my projects in production. So I will cover first implementing basic software backend monitoring, then adding ML monitoring and how you can use relatively simply tooling to do it. So let's start with the basic software monitoring. So I want to cover the basis here, especially for the pure data scientist, maybe lacking a little bit of production experience. That's why I'm going to cover it real brief. So everybody experiences incidents. So even the really big professional software companies like Google or AWS have regular incidents. That's why they have a health dashboard where they show, okay, this service is experiencing slowdown or worse, and this is when it's coming back up. So you can see that this is unavoidable. It's an unavoidable problem that you will have problems. And the difference between the good companies and the companies which could improve still a little bit is that you detect it fast and that you act on these problems based on their severity. So you want to know, are your customers experiencing a slowdown or do they get weird responses? And maybe you're even losing money immediately or one of your customers is losing money. So it's really important that you detect fast and then you act based on the severity. Typically, there are 3 types of severities. There's like severity level 1, which is critical with a high impact, and you need to react immediately. Then you have level 2, which is major and significant, and you want to react kind of fast, but you have a little bit more time. And then there's level 3, it's a bit more minor, so you have more time to fix it, but you still want to detect it. So how fast do you serve a request? The traffic, how much requests do you get per second? And the errors, so do any of these requests fail? And fourth signal is saturation, which means what's the load on your network and on your servers. As you can see, we're focusing on symptoms of something, not the cause. So this means probably your end users are feeling some pain if you get one of these alerts. So they have a slowdown or they're experiencing errors. And if you have saturation gives an error, it means the pain is coming soon and you get a bit of a head start. I recommend to use this for all of your products. This also applies in the batch use case. So if you don't have a production service that gets regular requests, but you process it in batch, let's say once a night, you still want to check your latency, so how much time do you typically take and monitor it. If it takes usually an hour and then it suddenly takes 6 hours, you want to know that. Is it in time for when your customers want to consume your predictions? Traffic is identical. How much traffic do you get? Is it sometimes a lot more, a lot less? That can point to a problem. And errors, especially interesting in batch processing, libraries handle this differently. Some libraries fail if there's one point in the batch that has an issue, and other libraries just silently eat this error or give you a warning that you might miss. So you want to find out how to collect these errors and have them as a metric. Okay, so how can you monitor these 4 metrics? These are like the ground metrics that you should have. Typically, you have a live dashboard. This is one I brought to you. This particular one is Grafana, but there are many different dashboard tools. You can also play with it. It's at play.grafana, and you can Google for the 4 golden signals. So you can play with this dashboard. You can adjust the time frame. It's really neat. And we typically use that to show your performance over time or check possible issues during an incident. And you can also use it to do regular performance reviews of your application. So how fast is it? Does it have spikes, etc.? Next, what you do is, if you have such metrics, is you put an alert. So alert means you want to get notified if one of these metrics is too high or too low. I put here an example by CloudWatch, which is by AWS, but many different vendors, so whatever you have will probably have a similar functionality. There's also one in Grafana. You can basically say, this is the metric, and if it is over or under this threshold, please alert me, and then you have different options. You can get an SMS, an email, a pager. And if it's an important alert, this often goes to 24/7 on-call people who immediately look at your application. For example, it's down and it shouldn't be down. But then there are other alerts. Maybe you fix them when you come into the office the next day. So is this kind of traditional monitoring enough for machine learning applications? I brought you a picture here from a Google paper called Machine Learning Test Score for Production, and you can see that the complexity of machine learning applications is higher than classic back-end software engineering, and that's mostly because there are diverse data-related things that you have to monitor. For example, the data itself, skew between training and production, the model updates, the model training, pipelines, etc. So you can see it becomes more complex. And I can testify to that from my personal experience, that we had diverse set of bugs that were not covered by the traditional monitoring, and I give you some examples here. For example, what can happen is that the input data changes. So the client called us, and it was a fraud model, and for some reason the unit of one of the numerical input was changed, and this doesn't give an exception because it's still a number, but the unit changed from seconds to milliseconds, and this was a very important feature, so the model immediately lost prediction quality, and this caused a lot of commercial costs because fraud was not detected. And as you can see from the previous monitoring slide, this wouldn't be covered. Another time we had an external service which migrated their data storage, which we called for to get article metadata, and they migrated their storage, and the new storage had some of the fields less filled. So immediately when we switched over to the new endpoint, we used these fields and they were less filled, so immediately we had quality degradation, so we could detect and switch back and tell them to please populate these fields before we try this again. Another reason is aggressive post filters. So in many applications you have the model, but then there's some filters applied on top of what your model says. For example, we had the case where this was an optional field, and if it's an optional field and it's not there, nobody's going to log a warning. So if it goes away over time, you want to know that. Another example is we had an on-sale filter that worked really well when it was created, which happened to be during sale season. And then we moved into non-sale season. There were barely any articles on sale, so this module looked really bad. So how are you going to detect this? Then I have some other examples. You can have some bugs in your own code, like simple bugs, like we wanted to get the last 10 orders, but we got the last 10 articles instead, so just mistakes you make. Or the model is automatically trained and released if you have continuous release of models, but the newest batch is worse, for example, because the training data had a problem and you didn't catch it. We also had funny examples where the TensorFlow version was updated and we didn't have it properly pinned, so you can have all kinds of these issues in production. And the last example is, especially in bigger companies or when your client is external, they don't always tell you how they're going to use your model downstream. So sometimes they make changes. In this case, the client suddenly used the model in the non-login area. So we got a bunch of completely differently distributed traffic than we got before. And maybe you need to adapt your training data to the new situation, but you definitely want to know if something like this happens. Okay, so this was a bunch of examples just to tell you that there's a lot of things that can go wrong, and none of these are caught by traditional monitoring, which is also important. You should have it, but it's not caught. These things are not caught. And very funny is that these things cause a bigger commercial impact than most of the modeling that you work on. So if you don't catch that, you work on improving the model by 3% or something like this. But such a bug can easily cost you a lot more, 10% more, and you won't notice. You will think it's devolved over time or something like that. Okay, that's why we need additional machine learning monitoring. Let's have a look at a practical example that I brought that we can walk through. So this is one of my use cases. I'm currently working at a bank, so we have some private loan offers that you can compare via a comparison website. It's one of our offers, so you go to Check24, for example, and say, I would like a loan for my new car. And then what this platform does, it calls a bunch of banks in the background, and they all call the credit bureau because they want to know what's your credit score, do you have pre-existing credits? And that's not so great for the banks because we all call this credit bureau, they all charge us, and the uptake rate, of course, you're at most going to take one credit and maybe you're just looking what you can get as an interest rate and you try a few times. So this is very expensive for us. So it would be nice if we could tell with a really high certainty which people will be rejected, and we reject them without calling the credit office. So that was the idea. Could we develop a model for that predicts if the loan is rejected or accepted? We have application data from the last month, and we don't know, the unknown in this problem is the credit agency response. So it's existing loans at other banks, credit scores, and maybe you defaulted in the past, stuff like that. And we have a bunch of fields, application information, like how much money do you want, what's your income, what's your rent, what's your employment status. Some configuration from the process, age limits, current risk configuration, past applications by the same person, and some other fields like is it a customer, what type of loan, etc. So this, remember, this will be our example, and let's now walk through what we should monitor for this. Okay, generally my argument would be that we would like to do symptom-based monitoring, very similar to what we do in backend engineering. We want to catch the customer pain. So I would say we prioritize our monitoring backwards from the output, and we start to the right, and I will walk you through each of these stages, and let's start with evaluation metrics in production and stakeholder concerns. Okay, so a very common question I get when I talk to other data scientists, they want to put the model into production is there a way that I can monitor what I evaluated on the evaluation set also in production? For example, in this case, precision and recall. And maybe you can. It depends on the type of application that you have. So do you know the target of your prediction close in time? There's some problems in production that where you cannot have it. Typically is it could be an unknown result. So in the case of fraud, you get a request. And of course, if you think it's fraud, what are you going to do? You're going to decline this loan. You're not going to have a look, typically, and because that's the purpose of the model. So in some cases, the purpose of the model is to reject something or to make a decision, and then you don't know the target value. In this case, you would have an unknown result. Then sometimes you have machine learning models where you have a delayed result. Let's say you're predicting how fast a parcel is going to be delivered, and you say it's going to be 3 days. And then after 3 days, or whenever the parcel arrives, you get a call back and say, okay, this parcel arrived in 4 days or in 2 days, and then you have your ground truth and you can compare against it, but it's delayed. So that's not useful for real-time alerting if you get a bug or if you release a problem. And then third problem you can have is sort of a filter bubble effect, where the algorithm decides what to show and you don't know the outcome on unseen options. So this means also you might not know the ground truth for all the predictions you might be interested in. So my summary is you can monitor the evaluation metrics in production for some use cases, like namely if you don't have these challenges that I just explained. So if you can, you should do that. You should store the prediction and you store the target when it arrives, hopefully close in time. Then you calculate the evaluation metrics that you also use doing model development. For example, this could be a batch job, or maybe you have an endpoint on the service that you call customer clicked now, something like this, and then you have the metrics in your application. And then you add the metrics to the dashboard, to the same dashboard that I showed earlier, so you have all your metrics, these classical backend metrics and the other ones on your dashboard, and then you create an alert. For our example of the loan prediction, I already said actually we wouldn't have this information, because if someone has, let's say, a 99% probability to not get the loan, we would reject this request, and then we wouldn't know if we made a mistake or not. So what we did here is we created the production evaluation data of a few percent of users where the model is called, but it's not used for decision making. And for this data, we're letting these people through, even when the model says 99% rejection probability, and then we record the actual result and calculate metrics and compare them to the expected performance. This is a dashboard of such a situation of evaluation metrics in production. So I have precision and I have recall here. Every 10 minutes, this job runs on these people we let through. And then we can have real-time monitoring to see if the model still works as expected. And we also have an alert. So if it surpasses a certain level, then we get an email and we can have a look what happened. Okay, so let's get to my second recommendation of monitoring priority 1 is stakeholder fear signals. So often when you talk to stakeholders, they're not only looking at the upside of adding a model, they're also kind of worried to add machine learning to their product. So things that could go wrong are often front of their mind, not just the upside. So what I typically recommend is that you ask them for their worst case scenarios. So maybe they're worried if the service makes the wrong decision, or they're worried that it's uncertain, or that it's slow, or what should they do if it's not available, if it's down, or has slowness and timeouts. So I would put these fears into metrics and demo them. Okay, now we are pretending the service is down, or no, we're having like a really weird input, let's see what happens. And then you also add these to the dashboard and have alerting. So for example, with my loan prediction stakeholders, they were of course very worried that we would reject people who would actually get a loan, and then the machine learning model would make wrong decisions, they would lose business, and the people would be unfairly treated. So we added this live holdout set and said, if the precision goes below 95%, we get an alert, we immediately look at it, and we could take the model offline, etc. And then there's a second fear, they were worried that it would be slow. Of course, we knew that it wouldn't be slow, but you still have to cover their fears, right? So we added an alert. If the P95 percentile of speed is below, for example, 300 milliseconds, then we would also get an alert. Okay, so let's look at priority number 2. Priority number 2 is the service response, model predictions, and quality heuristics. Let's start with an insight that I had when talking to many of you that were a little bit confused when I was talking about monitoring metrics, because they only partly overlap with the training metrics. So the purpose of the training metrics is usually to estimate the quality of our model. So this could be precision, recall, NDCG, it depends on your problem. And they're only available if you can calculate the prediction against the outcome in production. But if they're not available or not available in real time, we need the second set of metrics for ML monitoring, which is monitoring metrics. And the purpose of these metrics is not at all to measure the quality of your model. This is like a fundamental shift in how you think about metrics. The purpose is not measuring the quality, but to detect something. So this means it's easier. They just must be related to quality, but they're not necessarily indicative of the absolute quality of your model. And they're much easier to implement. Okay. All the following things are such metrics. They're detection metrics, not absolute quality metrics. So one thing you should do is monitor the response distribution. So let's say your model gives an output, and then there's a prediction, and after this prediction there could be potential next step like a filter or some post-processing. What you want to do is you monitor the very last output that goes to the customer, because when this thing changes, it means something changes for your downstream users. This is a good catch-all technique because you don't need to wait for the true signal, and you can also use it if it's delayed. This can detect sudden shifts. For example, let's say your median or your 95 quantile of your score was at some value, and suddenly it's always been at this value, and suddenly it dropped a lot. So probably something happened. Then you can start investigating what the issue is. And it can also detect slow shifts. So if you say, typically we reject 30%, and then you say, okay, once this drops over 25, I want to be alerted. This can be sudden, but this could also be slow over time. And then, but you're definitely sure you get alerted, and then you can have a look what happened. This is also nice because this is more clearly related to a customer experience change than monitoring the input. If you have, so data input monitoring, right, we all talk about it, but it's not very clear if you have, let's say, 80 inputs and one of them changed significantly. You're not entirely sure if this has a significant impact on your output of your model, or maybe it's a less important feature. So this is very direct customer related, so I would always start with that as priority 2. How do you do this? There's different ways to do this. So there are the rule-based distance metrics, which is what mostly everyone does. It's quite easy. You look at quantiles, medians, you look at share of empty or insufficient outputs. You could also use a distance metric, for example, a Kolmogorov-Smirnov statistic, or D1 distance. This is what Google uses in their production stack for monitoring, or population stability index. There are different ones. Some of them are quite nice. I gave you an example here. So this is the one that Google uses, the D1 metric. It's basically similar to a histogram comparison. So if you have one distribution, it could be your distribution during training, it could also be yesterday or the same day last week. And then you have to the right the black distribution, and you want to measure how much the height of this bar changed. And this is how you can even visually see, like, are they the same or are they different? It's actually quite simple, but that's what they use. Seemed to work surprisingly okay. Then there's a second priority that I recommend because it's based more on human common sense, which I call heuristic quality. And it means that you create a use case specific human understandable quality indicator. If your response is really good, or maybe it's really terrible, or something that's just based on a common sense. So this doesn't have to be a great indicator of quality, it's just more like a baseline or something that should be fulfilled. I give you some examples. So when I was at Zalando, I used something like for a personalized use case, the share of actually personalized responses, because maybe we don't know the user or the algorithm didn't have enough articles. A really bad response would be if the response is less articles than requested, or if it's like a fallback, like a top-selling product, that would be bad. And I also said once in a talk by Spotify, and they do a personalized homepage ranking, and they had a heuristic that was the rank of the user's most used carousel. So if you always, let's say, click on your favorite band, or you always click on 80s songs or your favorite playlist or something like that, that would be your most used carousel. And then would be common sense if you have a personalized ranker that it shouldn't rank your most favorably used thing at the bottom. So this would be a nice baseline that you could monitor. What's that rank of your favorite one? No matter what personalized recommender you develop for the homepage, you can all benchmark them, and if one of them, a release, makes a drop, that's probably a problem. Okay, and then I have my third priority. That's actually very confusing to me. Everybody talks about that monitoring the input data. That seems to be on everybody's mind, but I would strongly argue to start monitoring your output data. So for me, this is priority 3. It's very useful, but I would only start tackling it once you covered your other bases and you're fine with it and they're working and you're detecting things, because this creates more noise and it's not directly user pain related, your downstream user. So this is also useful, especially if you're more mature in your ops practices. And what you do is you monitor your input and feature distribution. Okay, just to be clear, I do recommend you do this, but not as the first thing. You can start later, and once you're clear that everybody knows what to do, you're already detecting incidents, it's clear who will fix, etc. Okay, so what you do is you compare the difference between serving and training, especially relevant when you go live. You have to do this at least once, but for ongoing monitoring, it's priority 3. You can also train on features that you logged. That's in the Google rules of machine learning. So they started this in YouTube, that they actually got their features, calculated them, logged them in a way, and instead of learning from a different pipeline, they learned from their own features that they logged. So if you have a high traffic important application, you can do that. And you can also compare the serving distribution over time, especially if there's a sudden shift that can indicate a bug. And if you can, it would be also good to monitor on subsegments. So sometimes only certain segments go blind, certain countries or certain payment option or whatever in your case, if you have different client, Android breaks but not iOS, stuff like that. The same rules apply, so you can use the same metrics, rule-based metrics or statistical distance metrics. Okay, some hints on how to implement these ML metrics. Do you need a machine learning monitoring tool? There's a bunch of them in the market. There are full-featured tools, SageMaker, Selden, and then there are special ones just for monitoring. I'm in contact with many ML ops practitioners, and I try to find out what they're doing. And it appears to me that everybody is like kind of interested, but not fully convinced that this is needed right now. So my current stance is that you start simple and you reevaluate later if you need one of these solutions. If you have a pure data science product, or if you're starting from scratch, or maybe you're very advanced, then you consider a full-featured platform, might be worth it. But if your customer already offers monitoring services, so you don't need to set them up, some alerting, some dashboarding, I would actually recommend that you use what your company has. That has several advantages. You don't need to introduce a new tool. You can immediately start. You have everything in one dashboard, and it's usually sufficient unless your type of product really means that you need to do a lot of machine learning debugging, then probably at some point you need like more advanced tooling. And also I think it's kind of developing fast at the moment, maybe give it some time to mature. Okay, how do you implement it in practice? An example, like some example code. So I use Prometheus. You maybe have some other libraries where you can create a metric. So this is in your inference code. And now basically we move from batch to single point prediction. So it comes in and then you call model predict and you get a score back. And then you have a histogram that you just increase, say, okay, now I saw a score of, I don't know, 0.3, for example. And then you can later create a dashboard and alert if your histogram changes its distribution. For a more complicated calculation, so maybe you want to do these statistical measures, you can also log each response of your model to storage, like a database or maybe S3, and then you run a script, let's say every 10 minutes, and you calculate raw metrics that you also put either in a database or into a monitoring solution, and then you monitor on that metric. So it's like, from IT-wise, it's not very complicated, but I wanted to show you an example. Okay, takeaways. You should monitor the 4 golden signals, and you should monitor some machine learning metrics. You should prioritize, in my opinion, the output metrics, like response monitoring, or if you can evaluation metrics in production. And you don't need a new tool. You can use the tools that you already have, and you add a few metrics. Okay. So if one of you is now spontaneously motivated to join my team, we're also looking for a machine learning lead engineer. And you can ask me privately any questions. And I'm also generally interested to talk about your ops practices. There's a very cool machine learning ops Slack from people from all over the world. I put you an invite here. If you want to join it, I'm there. Different nice people are there. Okay, thank you. Now questions. Okay.
Thank you very much, Lina. So now we come to the Q&A session. As I said before, we use Slido. So the QR code is in front of the entrance, or you go to Slido, slido.com, and then you enter PyBER, and then you can ask your question. So I think we have the first question, Lina. Which metric would you recommend to monitor model input for perception data like images?
Like I said, I would monitor the output. And I have not monitored images. I would have to have a look. I also have a friend who works in a startup to monitor. I would probably ask him. So sorry, no image-based monitoring. But I read, Googling, but I would focus on your outputs first if you have that not covered.
Okay, the next question comes from Jonas. Where do you store your model predictions, including metadata needed for debugging like model service version, input data, etc.? Relational database, NoSQL, DB, any other?
Yeah. No, we don't store it in a database, so we log the outputs and predictions and features away on S3. And the service version is typically monitored with an endpoint on the service. Yeah.
Okay. The next question is, how do you prevent alarm hell?
Yeah, that's the whole point of my talk. So if you monitor the output, you're already sure that it is related to something changing for the customer. And then you slowly start adding stuff because, especially with data, people get very easily fatigued if there are too many alarms. So start with the output.
Okay. Like the next question is, how would you evaluate online models?
Haven't had that case, would need to think about it. Can't tell you spontaneously.
Okay. So we have two more questions. How do you monitor fairness and biases?
We currently don't.
Okay.
So, okay, I can give you a longer answer for this. This is not easy, right? You have to know what exactly you're monitoring. For example, I looked once and we found out that women get more rejected in the credits. Okay, but women also have a lower income in these requests. So you could make a reasonable case that if you have a lower income and it's just correlated. So I would say fairness and bias is always very, very domain specific. I cannot say that this is unfair, right? Because as a bank, if you have a certain income, you get a certain loan, right? So it's very tricky, and you need to make this very domain specific, and you need to think what exactly you want to capture and how you want to react with it. So I would say it's a worthwhile undertaking, but it depends on your domain a lot. So that's my less flippant answer.
Okay, so the next question is regarding alerts. Are the ML engineers in your team also on call duty, or only when the issue is escalated?
We are not on call, no. It's a little bit funny. I also always used to think that maybe we should be, also for some other cases, but for some reason these data-related products is not entirely sure to management that is it always that important and so on, because you can't always immediately see, right? There is no one calling, the service is not down and so on, but so far in many companies, the ML people are not on call, they fix when they come into the office.
Okay, the next question is, what's your take on open source tooling for MLOps, especially metric monitoring? Any promising packages?
I'm trying them all. I have not yet seen one that I find very convincing, but there are some really promising starts.
Okay. How do you act upon performance decrease? How do you decide to trigger an alert?
So normally I just look at the performance over time from the past. So I either calculate it on the offline metrics, or I implement the alert and look at it for a while, and then I just eyeball, say, okay, this doesn't go below 90%, then I alert on 88, and if I get too many alerts, I alert on a little bit less, so it's quite heuristic. I've seen some slides by Berkeley where someone calls for research how to optimally design a better alerting system, but so far it's just based on looking at what the metric does and then setting a reasonable threshold. And Grafana just released also some ML-based detection, so they're actually trying to forecast your graph and to find out when it's weird, you know. So that is also a nice thing to actually apply machine learning to our monitoring statistics. So I think some cool things are going to come in this space.
Okay, I think we have time for one more question. So do you recommend outlier and drift detection to monitor models in production?
Haven't needed it so far.
Okay, thank you very much, Lina.